Transformation, the second video. Triangle ABC has vertices A 1, 1, B 3, 1 and C 1, 2. Triangle DEF has vertices -1, -1, E -1, -3 and F -2, -1. So these two triangles are drawn on the grid. The matrix P represents the single transformation T that maps triangle ABC onto triangle DEF. So there is a matrix called P, and that matrix represents the single transformation T, which maps triangle ABC onto triangle DEF. So when you are doing a matrix question, you should be able to segregate the difference between the single transformation and the matrix transformation. So the single transformation comes under enlargement, translation, rotation, or reflection. The matrix transformation is mostly a 2 by 2 matrix which maps one triangle onto another triangle. Now let me first describe T, which is the single transformation. You can clearly see in the question, T is present. T represent the single transformation while P represent the matrix transformation. So the single transformation is the mirror image of ABC onto DEF. The mirror image of triangle ABC onto triangle DEF. You can use tracing papers actually, and you can trace triangle A and fold it along the line y equals to minus x, which you could image ABC triangle on DEF triangle. So the T, which is the single transformation, is a reflection. In simple English, it is the mirror image along the line y equals to minus x. So a reflection is mostly occurred through a straight line which takes the form of y equals to mx plus c. You know the form of a straight line is y equals to mx plus c. So a reflection is always along a straight line. The single transformation T, which maps triangle ABC onto DEF, is a reflection along the line y equals to minus x. You can use a tracing paper and draw this and check how it reflects along the line y equals to minus x. Then they ask you to describe the matrix which maps triangle A onto triangle B. So in my first video, I explained you how to use a matrix to map two triangles. First thing is you have to write the transformation matrix, which is P. And in this case, they have not given the matrix, so you just label it as A, B, C, D. And then you write down the coordinates of the triangle A in XY form. In the first video, I discussed how to write the coordinates in the XY form. So the point A is 1, 1. Point B is 3, 1. Whereas point C is 1, 2. And you write down the corresponding coordinates of triangle DEF, which the matrix P transform triangle ABC into triangle DEF. Thereafter, we are using matrix multiplication of row by column technique to find out the coordinates of the matrix P. To find out the matrix P. So how we do this? 3 times 1. It's A times 1, it's A. And B times 1, it's B. So A plus B is equal to the very first element over here, which is minus 1. Again, row by column, 3A plus 1B, 3A plus 1B, which is equal to the second element, which is minus 1. So we use the first row along with the first column, thereafter along with the second column, and we wrote two equations here. We can solve this simultaneously to find out what A and B is. Similarly, as you use a simple matrix multiplication technique, which is row by column, I will list the second row along with the first column. Second row, C plus D is equal to minus 1, which is over here. Again, the second row with the second column, which is 3C plus D, which is equal to minus 3. So we can solve this and we can find out what are the coordinates A, B, C, D, and we can fix it to the matrix P, which labeled as A, B, C, D, that is 0, minus 1, minus 1, 0. So according to this question, the single transformation is the reflection along y equals to minus x, and the corresponding matrix is 0, minus 1, minus 1, 0. The next part of the question is the diagram show triangles AB. In this case, CD is there in the next part of this question. So I will say that the diagram shows the triangle AB. The single transformation P maps triangle A onto triangle B. Describe fully the transformation P. Now they are talking about the single transformation. I will repeat again. The single transformations are enlargement, reflections as we did in the previous sum, and rotation, translation. So according to this, how have A moved on to B? You can clearly see that this is not an enlargement. Triangle A and B has not enlarged enough size. But it also have not rotated, neither reflected. Then it is a translation. What do you mean by the translation? Where we can check how one point has moved to the other point. So this point over here has moved 1, 2, 3 movements to the negative direction, which is minus 3. That's it. It has not moved to the positive direction. As well as it has not moved along the y-axis. It has moved along the x-axis. Let me show you. Here, this point over here has moved 1, 2, 3. So it has moved negative 3, where it has not moved vertically along the y-axis. It has moved only along the x-axis. So the movement of the x-axis is minus 3 and the movement of the y-axis is 0. So it's a translation which triangle A has mapped onto triangle B via a translation minus 3, 0 vector. So in a case where you choose translation as a single transformation, you have to mention the translative vector, the vector which transforms which maps triangle A onto triangle B. Next part, the single transformation Q maps triangle A onto triangle C. Describe fully the transformation Q. Again, they talk about the single transformation, not about a matrix transformation. You can clearly see that the triangle A has changed its size. So it has flipped. Okay, it has flipped. It has not enlarged, but it has flipped. So this is not an enlargement. This is not a reflection. Neither it's not a translation. It is not a walk. It has not moved. The original figure has not moved. When it moved, it has changed its size. So I'm going to pick this as a rotation. So when you're writing about a rotation, when you describe the rotation, you have to find out what is the center of the rotation, as well as you have to mention how many degrees it has rotated and whether it has rotated clockwise or anti-clockwise. Now look at this. You have to use some tracing papers to do this. So you can mark 0, 1 as the center of the rotation, and you can trace A onto a tracing paper, and you can hold the tracing paper at 0, 1 and move 90 degrees anti-clockwise. At that time, you will get the image C. I repeat, you trace triangle A onto a tracing paper. Hold the tracing paper using a pencil at 0, 1, and you rotate 90 degrees anti-clockwise, where the original figure A will map onto C. So how it has transformed via a rotation of 90 degrees anti-clockwise with center 0, 1. Nextly, the reflection R maps triangle A onto triangle D. Find the matrix that represent reflection R. So now you can clearly see they are asking the transformation matrix, not the single transformation. If I speak about the single transformation which maps triangle A on triangle D it's directly, you can use a tracing paper again and trace triangle A and fold it along the y-axis. So the single transformation is a reflection along the y-axis. The single transformation is a reflection along the y-axis. But they are asking from you what is the matrix which map triangle A onto triangle C, such that we discussed a lot of questions under matrix. We discussed a lot of questions under matrix transformation in the previous video. So we first write down the matrix which we use to transform triangle A onto triangle D. A, B, C, D are the elements of matrix R, which you don't know. You use R and you transform the triangle A, which has coordinate 1, 2, then 1, 3 and 2, 3, which maps onto triangle D, which is corresponding elements are -1, 2, -1, 3 and -2, 3. So we use R, which maps triangle A onto triangle D. We use basic matrix multiplication and simultaneously we solve it to find out the elements of A, B, C, D, which is -1, 0, 0 and 1. With that, the diagram shows the point E, F, G, and you are asked to enlarge with the center E, which maps F onto G. So we have 3 points. You are going to use E as the center of the enlargement, and you're going to map triangle F onto G. So the first thing is the F and G exist onto the either side of the center of the rotation. Sorry, the center of the enlargement. F and G exist to both the sides of the center of the enlargement. At that time, definitely it's a negative scale factor. So E to F you have a distance of 1, but E to G you have a distance of 2. So from the center, you're going to enlarge F onto G. So you can see the gap 1 has become a gap of 2. So E is the center of the enlargement. Because F and G exist to both the sides of the center of the enlargement, we call it as a negative scale factor of 2. This distance is 1. So this distance is 2. So F has doubled its distance and gone to G. So we call it as negative 2 scale factor. The coordinate of the image of 0, 4. The coordinates of the image of 0, 4. So they are asking from you what is the coordinate of the image of 0, 4, which is when you transform using the same center of the enlargement, you use the same center of the enlargement, and the coordinate is 0, 4. So from 0, 4 to the center of the enlargement, you have a gap of 1. But you have to enlarge it negative 2 of its size. So from here we are moving 1, 2. So the point 0, 4 will move on to point 3, 1. In center of enlargement is here. From center of enlargement, the distance to the point 0, 4 is 1. So since it's a negative scale factor of 2, you're going to count it as 1 count, 2 counts. So we are at 3, 1. The coordinates of the image of 0, 4 is 3, 1.